Hi everyone. Okay, we're going to look at our next topic today, which is factorising, HCF, okay, highest common factor. So this is where you'll see it sometimes in worksheets, etc. Alright, just shorthand for highest common factor, which we have looked at previously in maybe first, second year, looking at factors of numbers. Alright, so that's what we're going to be using today to be able to look at this new algebraic manipulation. Okay, so we get 6 questions here, and we're asked to factorise each question. Now, factorising is the inverse operation of expanding our brackets, okay? So hopefully these questions are actually fairly straightforward, just using our knowledge of expanding brackets and kind of reverse. Now, to factorise these, what we're wanting to do is find the highest common factor of each term. Okay, so for this we'll be looking at the coefficient of our x and our kind of constant at the end, the number. So I'm looking at what can I divide 2 and 6 by, and that would be 2. Okay. So if I take 2 outside, 2 bracket x plus 3, we could expand out to check. So 2 times x would give us 2x, and 2 times plus 3 would give us plus 6. And that would be it factorised. Okay, so same process with number 2. We're looking for the highest common factor of 3 and 9, which is going to be 3. So 3 times p would give us 3p, 3 times 3 would give us 9. And we need our subtract in there this time, okay, rather than our addition. Alright, question 3, 14t subtract 49, so we're looking for the highest common factor. So a factor of 14 and 49 is going to be 7, okay, and that's then going to be 2t minus 7. Alright, so that's the first one where we've not got a unitary coefficient, we've got a number next to our variable term there, which is perfectly fine. Okay, now the order could be changed up slightly, so we've got the number first and then our variable second, that's completely fine. Again, looking for the highest common factor, so it's quite easy to spot here, they're both even, so 2 could be a factor. However, 2 is not going to be the highest common factor, so it wouldn't be fully factorised if we took 2 out. So we are going to take 4 out. Okay, and that's going to be 7 minus x. Okay, so 4 brackets 7, subtract x. Okay, question 5. We are looking for factors, okay, and if we notice with 5, it's the first one that doesn't involve constant terms, it's 2 variables, it's 2 letters. That's fine. So we're looking at what's common to both of these here, which is going to be x. So x times x would give us x squared, and x times plus 1 would give us x plus 1. Okay. And last one, slightly different again. We have 3 terms. It's fine, we could have as many terms as the question required. Okay, but this time we're going to look for a number and a variable as a common factor. So 3, 9 and 27. 3 is going to be our factor. And then x to the power 4, x cubed and x. X is going to be common to each one, okay? So 3x is our highest common factor. So 3x times x cubed will give us 3x to the power 4 plus 3x squared. 3x times 3x squared will give us 9x cubed minus 9. Okay, and that's a quick introduction to factorising using the highest common factor.